Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice using StatCrunch to perform hypothesis testing and construct confidence interval estimates for two population standard deviations, or variances. Let's get started. So to practice using StatCrunch, we're going to look at a problem that we looked at previously. Who talks more, men or women? Only this time, instead of looking at the mean values, now we're going to look at the variance between each of these different groups. So the claim that we're looking at is that the number of words per day spoken by men is going to vary more than that of the women. In other words, the women are more consistent with the amount of words they produce than men are. Yeah, I don't know where this is going to go. Another battle of the sexes here, but you can see we've got the same 7 standard questions that were asked with these type of problems. And there we have our sample stats. They're in the table on the right, which we've seen before. So let's get started. Keep in mind that with the F test, we're going to assign the sample with the larger variance, which is also the one with the larger standard deviation. So here we've got the larger standard deviation assigned to the men because their standard deviation is higher than that for the women. So that's why the grouping is the way that it is. So first we're asked about the hypotheses. So to construct the hypotheses, as always, we're going to think about the claim that's being made. In this case, the claim is that the daily number of words spoken varies more for the men than for the women. And since the men have the higher variance or standard deviation, then that's going to be group 1. And the women then are going to be group 2. So the variance for the first group is going to be greater than the variance for the second group. That's the claim. We can divide both sides by sigma 2 squared, and that gives us this expression here. Remember, the null hypothesis is by definition a statement of equality, so we're just going to set those two quantities equal to each other. And typically this is going to be your null hypothesis when you're working these types of problems. Okay, that the quotient of the two population variances is going to be equal to 1. Typically our alternative hypothesis comes directly from our claim. There's no semblance of equality here with our claim, so we can just adopt that as our alternative hypothesis. So we've got a match here with our claim, and the inequality sign there, the greater than sign, is like an arrow pointing to the right, says we have a right-tailed test. Next, we're asked about the test statistic. We can calculate this using StatCrunch. Just go to Stat, Variant Stats, to Sample with Summary. In the options window that appears, go ahead and enter your information in. Keep in mind that you've got to square your standard deviations if you're not given the variance. So we're not given the variance in this problem. We were given standard deviation. So we've got to square those numbers to put them in. Okay. The other thing you have to remember is that the larger number goes with the first sample. So make sure you put that larger variance in for sample 1, so that your test statistic can come out right. And then once you put that in, make sure everything is kosher with the hypothesis test region. Hit compute, and out comes your results window. And you're just going to read that test statistic like we've always done. It's that second to last number there in your results window. The p-value is always going to be the last number listed there in that results window. So same as we've always seen. And you just take these numbers directly off. There's no need to adjust anything. How are we going to decide the null hypothesis? Well, we can do that with a p-value and the same criteria that we've always used. If you're inside the region of rejection, reject the null hypothesis. If you're outside the region of rejection, you're going to fail to reject the null hypothesis. So here's what we're looking at, 1.39 for a critical value on a right-tailed test. So you can't really see the right tail of the distribution here. It's been cut off, but rest assured It is there. This is our critical region over here on the right, even though you can't see it. And the p-value we get from our results window that we saw previously. So looking at that p-value, 0.0284, that's going to be greater than the 1% alpha that we were asked to test at. And so we're outside the region of rejection, therefore we fail to reject the null hypothesis. Alternatively, we could use the test statistic here. 1.31 is just going to be just to the left of that critical value 1.39, that is the boundary of the tail, that is the rejection region for our distribution. And so we're outside the tail, therefore we're outside the region of rejection. We fail to reject the null hypothesis. Note that if we had a different significance level, say 5%, we would have reached a very different conclusion. If our alpha level was 5%, then we'd be inside the region of rejection and we'd reject the null hypothesis. So sometimes it does make a big difference what you select for your significance level. If you select one thing, it goes one way. If you select something else, it goes the other way. Typically with these problems you're working, the alpha level is selected for you, but in the real world, that's not the case. So you've got to make decisions about what to select. And sometimes it goes one way, sometimes it goes the other, depending upon what you select for your significance level. What do we conclude from the hypothesis test? Well, by now you should have that pattern down. So did we reject or fail to reject the null hypothesis? Do we have a one-tailed or two-tailed test? The answers to those questions lead you to select answer option B as the answer. Why answer option B? Well, notice where each of the parts of this is coming from. So we failed to reject the null hypothesis, therefore there is not sufficient evidence. We have a one-tailed test, so we're going to support the claim, and then the rest of the statement just comes from the claim itself. Confidence intervals. Here we're asked what is the appropriate confidence interval. So you've got to determine what your confidence level should be. So going back to those options window in StatCrunch, we're going to flip that radio button down to confidence interval. And notice here for our confidence level, we're taking 1 minus 2 alpha. Okay, that's because the claim and the alternative hypothesis matched each other. If there was a mismatch between the two, then we'd say the confidence level is 1 minus alpha. But we don't have a mismatch. Those two are the same. Therefore, 1 minus 2 alpha to accommodate the two populations that we're testing. So alpha is 1%. Therefore, confidence level is 1 minus 2%, which is 98%. Press compute, and out comes our results window. And we can read our lower and upper limits from the table just like we've always done. And so there we construct our confidence interval. What do we conclude from these results? Okay, well, what we saw before when we were testing differences, okay, is that you want to look for 0, okay, because if the two values are the same and you're subtracting them, you get 0 out. Well, here we're dividing. So if the two samples are the same, then you're going to get 1 coming out of the division. And so 1 is the number that we want to look for. Is 1 inside or outside of our confidence interval? Well, here 1 is inside the confidence interval. And therefore, because our confidence interval contains the number 1, we conclude there is no difference in the variation of daily words spoken by men and women. Okay? Note this is the same conclusion that we got earlier, okay, with the formal method of hypothesis testing. Okay, the variation of words spoken by men and women appears to be about the same. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.